Welcome all. Now I am going to discuss question number 21 from the GATE 2018 paper Electrical Engineering. The question is the positive, negative and zero sequence impedances of a 125 MVA 3-phase 15.5 kV star grounded 50 Hz generator are J 0.1 per unit, J 0.05 per unit and J 0.01 per unit respectively on the machine rating base. The machine is unloaded and working at the rated terminal voltage. If the grounding impedance of the generator is 0.01 per unit, then the magnitude of the fault current for a B phase to ground fault in kiloamperes is. To know the detailed modeling of fault analysis, audience can go through the given NPTEL video link. Let us discuss the important data to solve the problem. In the question, it is asked to find out the B phase to ground fault, which means that is LG fault, and it is denoted by IF, which is given by this expression EF divided by Z0 plus Z1 plus Z2 plus 3ZF, where EF is the rated voltage in per unit at the generator terminals. Usually it is 1 per unit. Z0 is the zero sequence impedance and Z1 is the positive sequence impedance, whereas Z2 is the negative sequence impedance. Finally, ZF is the fault impedance between the generator and ground. Using the above information, let us solve the problem. First, we will discuss about the given data. Given it is rating of the generator is 125 MVA and the voltage line to line, that is RMS value, that is equal to 15.5 kV, and the frequency of the generated voltage is 50 Hz, and the machine positive sequence impedance Z1 is J 0.1 per unit, negative sequence impedance Z2 is equal to J 0.05 per unit, zero sequence impedance Z0 is equal to J 0.01 per unit, and ZF is equal to J 0.01 per unit. Finally, we need to find out the fault current of the B phase to the ground. We need to find out the actual value of the fault current B phase to ground. So, as we have discussed, B phase to ground rate. B phase to ground means that is LG fault. So, LG fault is given by this expression, that is EF by Z0 plus Z1 plus Z2 plus 3 times of the fault impedance that is connected between generator terminals and ground. So, EF in per unit we need to find out. EF in per unit, that is equal to E actual by E base. That is E actual is 15.5 kV, right? And also E base is 15.5 because only one generator is there. So that is 1 per unit. So IF is equal to 1 by Z0 is J 0.01 plus Z1 is J 0.1 plus Z2 is J 0.05 plus 3 times of the ZF, that is J 0.01. So if we solve, we will get IF as 15.789 per unit. But we need to find out the actual value of the fault current between B phase to ground. So, IF per unit is equal to IF actual by IF base. So, we need to find out the IF base. So, S base is equal to root 3 into V base into I base. S base is 125 MVA, right? Root 3 into V base is how much? 15.5 kilovolts. So, I base is, we need to find out. So, from this we will get I base as 4.656 kilo amperes. And we got IF as 15.789, right? So, 15.789 is equal to IF actual value we need to find out. IF base is 4.656 into 10 cube, which means IF actual is equal to 15.789 into 4.656 into 10 cube. That is how much? 73.52 kilo amperes. So, the magnitude of the fault current for a B phase to ground fault is 73.52 kilo amperes. Thank you.